This is lesson one on two-way frequency tables with RStudio. So in a survey, 100 students were asked if they type or write their math work and if they prefer to use pen or pencil. So 40 students prefer to type. So if you look here, the type number is 40. 30 students prefer to write in pen. So here I would put in 30. And then 10 students prefer to type and use pen. So if you look here, if you remember, 40 students prefer to type. So if I did this type is 40 total. So if I did 40 minus 10, this is going to give us 30 here. So on here, I have 30 plus another 30, which is 60, plus 10 is 70. There's 100 people surveyed, so this has to be 30. So how many people prefer to use a pencil? Well, 30 plus 30 is 60. How many people prefer to write their work and use pen? So to write and use pen is 30. How many people prefer pencils and typing? So here's pencils and typing, that's 30. How many people prefer pens or writing? So here pens is going to be 10 plus 30, which is 40, or writing, so I add the other 30, that's going to be 70 total. How many people prefer pens or typing? So here's pens or typing. So we have 30 plus 10 is 40, plus another 30 is going to be 70. And then here, what's the probability that a person likes pens and writing? So pens and writing is 30 out of 100. So we can go 30 out of 100, which is 0.30, or just 0.3. What's the probability that a person likes pens or writing? So again, remember pens or writing was 70 out of 100. And as a decimal, that's 0.70. So we're going to look at the R code now for that. So here, the data, what we can do is create a matrix. And the matrix actually goes down the column. So I had 10, 30, 20, 40. So I run that. The row names are going to be type and write, and the column names are going to be pen and pencil. So then I convert the data to a table, and then I display it, and I have 10, 30, 20, 40. And if you look here, I needed 10, 30, 30, and 30. So what I need to do is go back here. It was 10, 30, then I have 30 and 30. So I just go back, change the code, and then double check to make sure it says what I want. So I have typewrite, pen, and pencil. I have typewrite, pen, and pencil, and then 10, 30, 30, and 30. So going back, I have 10, 30, 30, 30. Okay, perfect. So now what we're going to do is move on to problem one. Or task two. Scientists are studying the association between hair color and eye color. 80 subjects are randomly sampled, and then the hair and eye color are shown below. What does the 35 in the table mean in terms of hair color and eye color? So that 35 means 35 people have brown hair and blue eyes. How many subjects have brown eyes? So if you look here, 10 plus 23 is 33. How many subjects have blue eyes or blonde hair? So here we have blue eyes. So we have 12 plus 35 plus 10. So if I add all those up, so 12 plus 35 plus 10, that gives us 57. How many subjects had blue eyes and that should be blonde hair there? So how many subjects had blue eyes and blonde hair? So blue and blonde is 12. How many subjects don't have blonde hair? So that's brown hair. And don't have blue eyes. That's blonde. That's just brown eyes. So that's just going to be 23 there. What percent of the subjects have blue eyes? So if I go 12 plus 35, that gives me 47. Out of the total there is 80. And then I can convert that to a decimal by just doing 47 divided by 80, which is 0.5875, which equals 58.75%. Just slide the decimal 2 spots. So what percent of the subjects have brown eyes or brown hair? So here, brown eyes, we go 10 plus 23 plus that 35. And that gives us 68 out of 80, which equals 0.85, which is 85%. So what percent have brown eyes and brown hair? So that's 23 out of the 80. Which is 0.2875 or 28.75%. All right, so here we have cell phone information, who has a cell phone or doesn't, and different age groups. So how many people are 0 to 10 and do not have a cell phone? That's 70 people, or 17, I'm sorry. What percentage of people surveyed are 0 to 10 and do not have a cell phone? So that's 17 out of, and then I just need the total. So I add 3 plus 17 plus 19 plus 20 plus 17 plus 3 plus 1 is 80. And 17 out of 80 is 0.2125 or 21.25%. How many people are 11 to 25 or don't own a cell phone? So here we go 17 plus 3, and then all the don't have a cell phone. So that's 17 plus 3 plus the other 17 plus 1, which is 38 out of the 80, which is equal to 0.475, which is equal to 47.5%. So here, how many people surveyed do not own a cell phone? So we have 17 plus 3 plus 1, which is 21 out of 80, which is 0.2625 or 26.25%. What percentage of people do not own a cell phone? Oh, that was how many people. Sorry, I answered how many. I did the percent part right here, so we can just copy this and put it there. And here, that was just the how many people was just 21. How many people own a cell phone? So we just add up this column, 3 plus 17 plus 19 plus 20, We have 59 respondents own a cell phone. And then what percent is that? Well, that's 59 out of 80, which is 0.7375. And then as a decimal, we just slide it 2 spots to be a percent, so 73.75%. How many people are 0 to 10 years old? 20. What percentage? Well, that's 20 out of 80. And that is going to be 0.25 or 25%. What percentage of people, 11 to 25 have a cell phone? So if you look here, 17 people out of the 20 people have a cell phone that are 11 to 25. So of the 11 to 25, 17 people have one out of 20. And then that is 0.85 or 85%. So now what we're going to do is create these tables by putting them in as matrices or matrices. So here I have my 12, 10, 35, 23. And then I have 2 columns. So again, you put your information here down as columns, and then you write your row names in and your column names. Now the order of this, you could put the column names and then the row names of the data first. And then you don't have to call this object your data. You could call it any object you want and then adjust these here. So as I do that, here's my data, column names, row names, change it to a table, and then display it. And then I just always double check. So does that actually display what I want? Does it go, as we look here, we have 12, 10, 35, 23, and then blue eyes, brown eyes, and then I'm checking for blonde hair, brown hair. So we did get what we wanted there. And now I'm changing the name of the object data. So really, if you wanted this to stick, you could call this one data 1 and then put all ones in here. And then it would save that you have data. But because we're recalling this for the second problem data, it's overwriting what we did for the first one. So just be mindful of that as well. So here's the second one. I have the data. And then here I'm changing the row names. And remember, we have people that ages are 0 to 10, 11 to 25, 25 to 40, and 40 and up. And then we only have 2 column names. And then we put that here. And then I just go double check, 0 to 10, 11 to 25, 25 to 40, has a cell phone, doesn't. And then we have 3, 17, 19, 20. So I just go double check here, 3, 17, 19, 20, 17, 3, 1. Okay, that's what I want. You always want to make sure that you're looking. When I wrote these, I actually made a mistake. I was like, whoops, I better go back and put them in. I'm used to things that put them in by rows. So as I made my matrix, I put these in by the rows. And the matrix one actually puts them in by the columns. So you could alternatively put these in with brackets as like 3 comma 17 bracket 17 comma 3 and then call that an object. So now you're going to practice and struggle with the practice problems. Put the 2A tables into RStudio using the matrix feature. Always double check that you're naming your column names, your row names, and you're putting them in by columns and not rows, then answering the questions.